Hello and welcome to Power Grid Expert, the YouTube channel about the energy distribution grid. Today we will have a look at measures to improve the power quality in the distribution grid. So let's get started. A few words about my person. I'm Power Grid Expert. I'm offering services and consulting in the field of the distribution grid. That might be installation, trainings, protection relay testing, general consulting, and so on. Let's start with the motivation. Why should the utility, why should a customer be aware of power quality? Very simple. We have electronic loads, we have inverters from solar parks, from wind farms, and so on. And they all generate grid interference. And the standards are setting limits for harmonic disturbances. So what does that mean? If I'm a customer, if I'm either a wind farm operator, or solar farm, or also if I'm a big customer for some industries, I have to adhere to a certain limit of grid interference I'm giving back to the energy grid that's supplying me. And the utility might measure that interference. So if these limits are reached, I have to do something about them. And this is why it's interesting to know the possible measures I can do in these cases. So what we are talking about the energy distribution grid, commonly between 1 and 50 kV. And especially today we're looking at the industrial customers and also those wind park, solar farm operators, which have their own connection to the distribution grid. Before I can think about possible measures to reduce the disturbances, of course I have to measure them. That is the process of measuring. I already shown in a video that is a little bit older. The link you can find above. Quick summary here, what's important if I want to measure the harmonics in my network. I really have to make sure, first of all, I have to know in which frequency range I want to measure. Do I want to measure in a frequency range given by a certain standard? Do I want to measure higher, like talking about supraharmonics, superharmonics, or even or something in between? And as soon as I know that, I can decide about the measurement device. And then I have to look at the measurement device, and I have to check if that device at all can measure in that frequency range that I want to see. And if I have the right one, then the next step is to decide about the right sensors. If we talk about low voltage measurement, for the voltage, not a big deal. Normally, as you can see here on the picture, we connect directly to the voltage, so I don't need to think about any sensors. But if we look to the current measurement, there is, like nearly always, some kind of a current sensor, CT, Rogowski, Hall sensor, whatever. And for all these sensors, they have a certain frequency behavior, and they have a frequency range that they are measuring within the given precision. So once I did decide about my measurement device and I'm sure about the frequency range, I also have to choose the right sensor for that. That is crucial. If I'm not using the right sensor, I might measure nothing in high frequency range. And I think everything is okay, but in fact, everything is not okay. I just don't see it. So that's important for the measurement. If I go to the analysis of my measurement, then of course I have to check for compliance of given standards for grid interference, talking about harmonic distortions. That really depends on the region on this earth you're living, so I cannot give a general general recommendation or limit that has to be adhered. So that has to be checked individually. If I find out that I exceeded those limits, I have to think about possible and, of course, appropriate measures, and that's what this video is all about. Let's have an overview about possible measures. First of all, on the network side, I can do adjustments. That is normally done by the grid operator. That can be grid expansion, that can be a better distribution. We'll have a look in those 2 points in detail right after that. And of course, as a second solution, all the measures on the customer side, exchange of the inverters, use of passive filters, use of active filters. And then there's a third group, which I will show you at the end of this video. So be sure to watch till the end. Network adjustments, normally on the side of the grid operator. What can we do? We can increase the short circuit power. What does that mean? That means we are reducing the impedance between the supplying transformer, high voltage and medium voltage, and my customer. That can be done by using thicker cables. That can be done by using parallel cables. All together, it's a costly thing to do. So maybe not the most popular solution in these cases. I can do network adjustments about the structure of the network. I'm aware that most utility operators are already doing that, but I want to show that this is also a possibility. What is it about? In this example here, we have the structure of a medium voltage network. There's a feeder 1, feeder 2, and the double bus bar here, and the power transformer here is supplying both of these feeders, and there's a standby transformer here, or that one is feeding other feeders not shown on this sketch. Our customers are marked here with those wind farms, and they are generating overall a distortion of my network. There's harmonics in my net, and they reach the limit. So what can I do in this case? I can think about a better distribution of those disturbancing of these customers that are disturbing my grid. And the very simple solution in this case would be to put one feeder to one transformer and the other feeder to the other transformer, and suddenly we are within the given limits and everything is okay. Of course, the distortion is still there, but much less because we're balancing it between the two transformers. Let's have a look at the measures on the customer side, on the plant side. For example, what can we do here? As a summary or as a start, first of all, we should have a look at our inverters. Contact the producer of these converters, ask him, do you have any solutions to reduce the THDI of your inverter, because I'm reaching a limit in my network or in my connection point to the grid. And if normally those manufacturers, this is not the first time, most probably you contact them about that, so they might have already like a tool set available. If not, you might want to look at another inverter with a lower THDI and a better smoothing in the DC link of that inverter. Then you can use passive filters. Passive filters, as the name is already saying, are filters that have no active parts, which gives them a long lifespan. Here is an example from Levalsa efficiency filter, purely passive filter, reduces, for example, the harmonics and also saves on your energy bill. So it's quite an interesting solution in this case. We have the active filters. The active filters, as the name already says, have some active parts in it, similar to the PFC modules in small switching power supplies. They are checking the signal, they are checking the disturbances, and they're at the same time creating a counter signal to remove those disturbances, at least a part of it. Active filters, as the name says, have active parts. And that's the main difference between active and passive filters. The big difference and comparison will follow in a video later. And the last thing, and that's for me pretty interesting, looking overall at these measures, what we can see is basically what's happening now in the medium voltage and also in the low voltage, medium voltage, high voltage, not yet, is what we know for decades from PCB layouting. So if anybody of you guys did ever layouts of PCBs in power electronics, in controllers or whatever, then he is well aware of all the EMC stuff he has to look at and follow. And with all the electronics in our networks, now we have to apply the same mechanisms, the same measures in our distribution grids. And that might include avoidance of capacitive coupling. So if cables are very close together on a long distance, that might lead to capacitive coupling. So don't put them too close together. Use shielded cables. If there is a disturbance, try to feed back these interference to the source, most probably the inverter. Use a uniform, as good as possible uniform reference potential. Use twisted cable also in the thick cable for the low voltage or medium voltage distribution. We can use twisted cables in communication and signal electronics. That is used since decades. In every Ethernet cable there's twisted cable. We can use the same here to avoid further disturbances. And of course, we should always avoid ground loops. On the right side, I have two examples about EMC optimized low voltage distribution cabinet, and also here about a shielded medium voltage transformer that is optimized for as low EMC as possible. And we're talking here about the electrical fields as well as the magnetic fields. So that's it. That's a quick summary about possible measures in case you want to reduce or improve the power quality of your distribution grid. I hope you like this video. If yes, I am happy if you click the follow button. If you already did that, then I'm happy about a like or a comment. If you have further questions to power quality, to distribution grids in general, feel free to contact me. My contact data is below in the video description. Thank you for watching.